All right, on to our very last talk of today. We have a speaker who has traveled a very long distance to be with us today, flown in from California, is that right? Yesterday. So we're absolutely honored to have Martin speaking to us today. But just before we start with that talk, I'm just going to give you a little reminder that this is your last chance to get involved in the competitions that are going on, because it's now just slightly after 4, and just about 5 o'clock on this very stage, we will announce those winners for the raffle and for the LinkedIn post competition. So if you've got a couple of photos spare, put that on LinkedIn. If you don't have any photos, take some now of this talk. So right now we have Martin speaking to us. Martin is the creator of Presto, creator of Trino, co-founder of the Trino Software Foundation, and CTO at Starburst. Prior to Starburst, Martin worked as a software engineer at Facebook and a software architect at Proofpoint and Ning. Over to Martin.
Thank you. Thanks everyone for sticking around. It's been a long day, so thanks for being here. I'm a bit jet lagged, so if you don't understand anything, it's me, not you. So I guess I don't need to introduce myself, but so let's dive right in. So there's been a profound change in the data analytics landscape over the last 20 years. If you think about what was available 30, maybe even 40 years ago, we had commercial data warehouses like Teradata, Oracle, and some other systems that were effectively commercial. You didn't have any options that were open source, that were easily accessible. They were expensive systems that didn't used to scale very much. In early 2000s, Google started working on, and they actually published papers on MapReduce and Google File System. And then the open source community created Hadoop as a counterpart to that. So that propelled the what's today known as data lakes, data lakehouses, and so on. It created the foundations and the technology for those types of systems. In around 2012, I was at Facebook with a group of other 4 engineers. We started working on Trino, what used to be called Presto at the time. And there was, at the time, only one system that was that could scale to the levels that were needed at Facebook in terms of numbers of users, size of data was being queried. Facebook had a warehouse that was 300 petabytes big. There was no system available that could handle that workload. So we set out to build a system that was faster than Hive. Hive was also created at Facebook, but it wasn't very fast, it wasn't very efficient. So we needed something that was better, faster, and more efficient. Since 2012, there's been a huge explosion in the, and you're not meant to be able to read what's in there, just look at the scale of that. There's been a huge scale explosion in the data landscape, all the set of tools that are available. This has been driven primarily by the availability of cloud technologies, which allowed companies and organizations to very easily deploy large infrastructure, take advantage of a lot of technologies that became available. And these days, there's basically one, maybe 10 different options for every piece of the data warehouse stack that you can think about. Everything from data ingestion, data management, security, authorization, authentication, visualization, clients, even table formats. Like there's options for everything. It's so complicated, you almost have to have a PhD to be able to figure all this out. When we created Trino, like I said, there was the only thing that was available at the time as an open source project that could handle the workloads of Facebook was Hive. It was slow, it wasn't very efficient. So our first goal was to try to make the life of our data scientists and data analysts at Facebook better. There was a data scientist that he said what became a famous quote, at least inside Facebook. He said, "It is a good day when I can run 6 Hive queries." So imagine you're a data scientist. Your job is to get insights from data, and all you can do is run 6 Hive queries. So you run a query, go take take a break, get a cup of coffee, come back. Maybe you got an answer, you wait more, and keep going. So we need to make that use case much more, basically more effective for users. But we architected Trino to be flexible and extensible, which allowed us to scale it up and handle other use cases, not just the warehouse, interactive queries over the warehouse, but also queries over custom data stores. So Trino has a way to connect to other data sources. It's very extensible. So it allowed us to run workloads against other data sources. Eventually, we built specialized data sources and deployments that allow us to use Trino for user-facing applications. Like we had an application for advertisers that they could just go to a website, click a couple buttons, and there was a query against Trino live, and it was designed to run 24/7, multiple geography, so there was no downtime. Then we also applied it to other use cases, like for example, the analytics backend for the A/B testing framework at Facebook. So everything that Facebook does, every action a user takes gets recorded, so they can do analytics and figure out, is it is a product having the traction they expect? Is it sticky? Is it not? So all that feeds into a system, and the analytics for that system is driven by Trino. And then in the last few years, other use cases like data transformations, ETL, big batch workloads. And everything at a very, very large scale. We had clusters ranging from a few dozen nodes to 800, 1,000 nodes. And we had, in the order of 40, 50 clusters of that size. So at the end, today and even a few years ago, Trino was the default engine for all the analytics at Facebook and these days in many companies across the world. So today it's used by companies across every industry segment. You have retail, entertainment, transportation, gaming, financial services, you name it. There are companies all over the world that use Trino. We have pretty large communities of developers and users in the US, in Europe, in India, Japan, China, and it keeps growing everywhere. So what is Trino? Actually, by show of hands, how many of you have heard about Trino? Okay, not many. How many have heard about Presto? Okay, well, Trino and Presto are basically the same ancestry. Like it's the same project that when we left Facebook, we continued developing as an open source project, and we changed the name eventually. Okay, so let me give you a quick overview of what Trino is. So primarily, Trino is a query engine. So you interact with Trino by submitting SQL queries, and Trino plans them, executes them across a large number of machines. So you can run on clusters anywhere from a couple nodes to hundreds of nodes. And it can take advantage of all the machines for a single query. So that means you can run massive amounts of computation for a single query. So you can run queries over very large scales of data. So at Facebook, I remember one time, one query process was like about a petabyte of data. So that's, at the time, like it was 5, 6 years ago, it was pretty large. So you can take advantage of a large number of machines, partition all the workloads, computation across all those machines, and run them very efficiently, very scalably. The SQL dialect that it uses it's based on ANSI SQL, so everything you know coming from other systems. If you have used commercial data warehouse systems, Teradata, Postgres, or even databases, Postgres, SQL Server, etc., you will will be pretty familiar to you. We have a couple of extensions, but by and large, we try to stay as close to a standard as possible because that makes it easier to integrate with third-party tooling. It breeds familiarity. So if you come from one tool, you can use Trino very easily. You don't have to ramp up too much. And Trino is extensible. It has a connector architecture, so it's very easy to add new connectors for new data sources. So as long as you can model a data source as a set of tables with columns and data types, Trino can query them. We also have extension points for adding functions and data types and so on. And fundamentally, it's an open source project. We open sourced it back in 2013, a year after we started the project. And we've been developing it in the open since then. Like I said, we have developers all over the world across many companies. Like some of the largest internet companies are involved in the project, for instance, like LinkedIn, Netflix, Lyft, and so on. If you are a developer and you like contributing to open source projects, this is a good opportunity for doing that. When we started in 2012, we had one data source. We could connect to Hadoop and process tables that were created for querying via Hive. So Trino could interact with those tables. Then over the years, the community has created connectors for many data sources. A lot of them ship with Trino itself. So if you download Trino, you get those data source connectors out of the box. Some people have created third-party connectors, and they either provide them in their own solutions or they make the connectors available for just deploying on a Trino installation. And you can see here there's connectors for data lake systems, Hive, Iceberg, Hudi, Delta Lake, also SQL databases like Oracle, MySQL, SQL Server, and so on, and then some NoSQL databases, Cassandra, Druid, and so on. You can even talk to systems like Kafka or Kinesis. So systems are not traditionally table-oriented, but they can be made to look like tables so you can query them. On the front-end side, it integrates with pretty much every tool you can think of. We have clients for different languages, Python, Ruby, Java, JavaScript, and so on. And then based on those clients, there's integrations into third-party tools, like BI systems, like, for example, Superset, and some tools that you may be familiar with as data analysts and scientists, like dbt and so on. So Trino has been used very successfully across a lot of companies, and I think it can be very useful for you too. You have to be careful though. There's one thing that happened when we were at Facebook. We said, okay, we have Trino. It's way more efficient than Hive. Hive was very expensive to run. So one of the things we tried to, we said as a data infrastructure organization is like, well, okay, let's try to migrate all the workloads from Hive to Trino so we can save money. We can reduce the size of our clusters. We can run fewer machines and so on. Well, what happened was that Trino was so much faster that everyone that was running 6 queries per day said, oh, I can run a lot more queries now. So instead of saving computation and money, everyone managed to use all the capacity that we had and do more work. Now, it's a very fortunate thing. Like they were able to be more efficient at the work they were doing and provide a lot of value for the company. But it's a double-edged sword. So don't think you can just save money by using Trino. You'll make your people more effective too. So if you have a data lake, or if you're thinking about a data lake, this is the bread and butter of Trino. We created it to support this type of use case when the terms data lake and data lakehouse didn't exist yet. Trino can talk to object stores and can talk to the Hive metastore, which defines the set of tables and with the columns and data types and so on. And it can query those tables. So it supports. Well, there's a couple of things couple of terms to keep in mind here. So there's a concept of table formats. Table formats describe how the data is laid out across files in an object store. For example, how are your, let's say you have customer data, how is that customer data going to be broken up into files and organized into directories and files in, say, S3 or Google Cloud Storage. There are, traditionally it was the Hive table format. In the last few years, there's a few other formats that came up, like called Iceberg, Delta Lake, and Hooey, which try to solve a lot of the limitations that Hive used to have in terms of being able to evolve your data, have transactional semantics over your data where you can safely modify the data without introducing duplicates or silently losing data, and generally be able to better manage your data lake. So Trino can query all of those. And not only that, it has some facilities that allow you to migrate from one data format, the table format, to another format. So if you have a Hive data lake and you're trying to migrate to Iceberg or Delta Lake, there are some facilities that allow you to do that easily and seamlessly. And then the second concept is the file formats. So within a table format, you have, or within a table object storage, you have a bunch of files. Those files can be of different formats. You can have anything from just raw CSV, text files, and so on, or you can have more advanced formats like Parquet or ORC. Those are columnar data formats. And one of the things about Trino is it can take advantage of those formats and the metadata in those data formats to optimize the execution of queries. It can selectively load portions of the files as it processes the queries to reduce the amount of I/O it has to perform against the underlying data store, thereby improving the performance of your query. You can take advantage of some of the metadata in the files, like those files, for example, summarize what data is in each of the columns, and Trino can take advantage of that to prune the set of files that need to be considered, so it can potentially filter out a lot of data without even having to read the files. And then, of course, because it can process across hundreds of machines and across hundreds of cores, it can look at all the files in parallel and return results to the user much faster than if you were doing them sequentially. On the client side, I mean, if you're a data analyst, data scientist, if your tools of trade are SQL, Python, etc., Trino supports a very powerful set of SQL features. I mean, SQL is the main entry point for Trino. On top of that, there are clients that can interact with it either by generating SQL or by allowing you to write the SQL and submit it to Trino itself. So if it has all the features from SQL that you would expect, like selecting from tables, grouping by columns, doing joins, like left joins, right joins, full joins, like all the joins types you expect. But it also supports more advanced features that are not usually available in many databases or data warehouse systems. Like supports analytic window functions. Well, that's actually pretty common, but it's one of those power features that if you're familiar with, you can be a lot more effective at your work doing SQL. It has support for pattern matching via a construct called match recognize. It's actually one of those features not supported by many systems. Supports for grouping sets and so on. It also supports a large variety of functions and data types. It can process geospatial data. It has an extensive set of functions for dealing with geospatial data. We actually use that at Facebook very extensively. There were a number of projects that required looking at mapping data. They were trying to figure out there was an effort to provide internet access to everyone in the world, and they were trying to figure out where are the areas of the world that didn't have enough coverage, and they use Trino for all the analytics for that. It has functions for analyzing JSON, transforming JSON, very extensive and powerful datetime management functions. So if you're dealing with datetime temporal data, very powerful set of functions for that. It also has some structures for that use data sketches under the covers to be able to process. For example, if you're doing distinct counts and you have a lot of data, you can use those data sketches to do it more efficiently. And of course, supports arrays, maps, and a set of higher level functions that allow you to transform and filter and process those maps. It supports table functions, which again is one of those power features. We're only just now starting to scratch the surface in terms of what you can do. These are functions that allow you to take a table and apply a full transformation to the table as part of your query. So we have a couple of examples of that, but there's going to be more that's coming in the future. One of the things that's coming very soon is the ability to define your own SQL functions using a SQL feature called routines. There's a dialect of SQL that allows you to define functions. It's like a scripting language type of approach. And eventually, in the future, we plan to add support for extending functions with other languages like Python and JavaScript and so on. As I said, there are clients for many languages. So if you are using Python, you can either use the Python client directly, or you can use libraries like IBs or some other data frames, libraries that integrate directly with the Python client to be able to talk to Trino. One of the powerful features about Trino, especially if you have data in different sources, you have data in your data lake, you may have a MySQL database, you may have an Elasticsearch, and you want to somehow connect all that data together, you can, of course, via the connectors, you can talk to those data sources, but one of the powerful features is that you can run a single query that brings in data from all those data sources. You can do an analysis over all of them at the same time without having to copy data from one system to another. And yeah, of course, like Trino was designed to be fast, low latency. So it supports interactive use cases. It supports dashboarding. Of course, assuming you have the right organization of your data and so on. There's a use case that has been growing in popularity over the last few years. This is mostly due to some features and capabilities we added in the last few years, like support for SQL syntax like merge. And we already had insert, delete, and update, but support for merge, integration with Iceberg and Delta Lake that allow you to do those operations more seamlessly, safely. You can evolve your data schemas without introducing problems by using Trino. So that set of features, combined with the ability to do granular fault tolerance for execution of queries, which allow you to run queries on larger clusters where machines can fail, and you don't want your queries to fail because of that. So when you combine all those features, you can then start using Trino as a tool for transformation. So things or workloads where people used to traditionally use Spark, for instance, or Hive, or MapReduce, over the last couple of years, 2 to 3 years, Trino has been able to do them more effectively. One use case is, for example, you have data, you ingest data into your data lake, has, let's say, event data, and you want to take that data and augment it with other data comes from dimensional systems, like dimensional data sets, like something that might be stored in a MySQL instance or something, or anything like that. You can run a query that transforms that data, joins it together, and writes a new table. And so that's one of the use cases that you can apply when developing data pipelines. So Trino is also known for being able to run at scale. Right? As I said, we built it to be able to run at Facebook. Over the data warehouse at the time was 300 petabytes in 2012, and then it grew over to over a exabyte size. When we talk about scalability, we're not only talking about performance and how much data you can process, how much how many users you can have. We also talk about the scalability in terms of the maturity of your data practice. And Trino can scale with your organization in that manner. So you can start, whether you're running, you want to run analytics over some data set that you have lying around in some set of files, to, I don't know, like if you're at a Fortune 100 company where you care about security, data governance, tracking who accesses what where and what they do with the data, being able to know what's going on with your systems, manage them, provide uptime for your users and so on. Trino can do all that. It has all the building blocks to be able to do that. We have some other tools like one of the side projects are in the Trino ecosystem is a gateway that allows you to run multiple clusters, and you can route clients to different clusters depending on different criteria. So you can scale out your workloads even further. You can partition your workloads and so on. So there's a set of capabilities and tooling that allow you to run Trino in your organization when and grow as you mature your practice in terms of data management policies and so on. So you can run, Trino is open source software, so you can run the code, get the code, compile it yourself. Obviously, you don't want to do that. You can download the package and try to figure out how to run it, but we offer, or the Trino project offers a number of different ways to deploy and run the software. You can run containers, Docker containers, virtual machines, and so on. You can run it on-premise, in the cloud, supports Kubernetes. We have Helm chart for that. And then basically you can either run it yourself, you can manage it yourself if you have the expertise and the interest in doing that, or you can get help from various vendors. There's, for example, Starburst offers a managed service called Galaxy. Amazon has Athena, which is built on top of Trino, and there are some other vendors that use Trino as the foundation for their system. So you have flexibility here, and again, you can start small. You can run it yourself. You can try it through one of these vendors, and then you can grow your system, grow your deployment, and be able to operate it effectively. If you are running, if you want to try it, Starburst is a good option. You can sign up very quickly, very easily. You can, through a few clicks, connect it to your data source, be it S3 or Glue and so on, and then you can run queries. And so if you want to try it, I encourage you to do that. This is my plug for the product we're building. So with that, if you want to learn more about Trino, we have a website. There's a Slack channel. If you're not, haven't joined Slack, our Slack channel, there's 10,000 people there. If you have questions, if you want to get help getting set up, get help get going with Trino, there's a lot of people there that can help you. If you want to participate in the project, contribute code, submit bugs, feature requests, etc., there's a link to the GitHub repository. You can just go there and file issues, get the code if you want to dive into it and figure things out. And finally, we have a Trino Summit coming up. It's going to be a virtual summit in December. If you want to join, just go to the website. There's more details there. If you want to talk present at the summit, you can also do that. There's a link to submit a proposal for a talk. So with that, we'll go to questions. Thank you.
Thank you very much, Martin. So we'll take some questions down here.
Yeah. Hi. Thanks very much for the talk. It's very informative and insightful. I don't actually work in this field, so it might come across as a bit a silly question. But given the size of the data sets you're working with, you can do SQL queries. Now, when you want to do data analysis, do you use special tools, or well, what are the tools you would use for analyzing this data to, make decisions with?
Well, I mean, at the core, of course, you have SQL. So if you are a power user, you can use SQL and all the features that come in the language for that. On top of that, there's integration with a number of tools. For example, if you use Tableau, you can plug it into Tableau and use all the capabilities of Tableau to do analytics. Superset can do that too. If you are a developer that knows Python, there's one of the tools that you can integrate with is IBIS, which is a data frame API. So you can write Python code to interact with Trino and then manipulate the data that way. So lots of options, depends on what your background is, what your needs are.
Thank you.
Shall we take another question? Is there, here?
Thanks a lot for the talk. What's next for Trino? What's exciting you for us as a project?
There's lots of things going on all the time. There's one project that we're actively working on right now is to revamp the core of the execution engine to make it more efficient. I mean, if you think about it, we built Trino in 2012. We designed to be fast and efficient, but as soon as we were satisfied that we were way faster than what was available at the time, we kind of really stopped looking at that as the main focus. I mean, we've made improvements over the years, but no systematic look at how can we make Trino faster. So now we are starting again to look at, okay, is there anything we can do at the low level in the engine to make it better? And we identified a number of things. For example, one of the changes that landed in a couple of releases ago, it makes aggregation queries 10 to 20% more CPU efficient. Just one change, and we have a lot on the roadmap for that. The other one I mentioned is the ability to define your own functions using a SQL dialect. Right now, if you want to extend Trino and add functions, you have to write Java code, which, of course, is doable. It requires a certain skill set that not everyone has. So now you will be able to do something as simple as create function, give it a name, arguments, and then you have a body that could be an expression or it could be a set of statements that are very, very simple. In the future, we want to extend that to support Python or JavaScript. So if you know Python or JavaScript, you can say create function, name, arguments, and then Python body. So that will be super powerful for anyone interacting with Trino.
Cool, thanks. That sounds exciting.
Are there any more questions, perhaps? You all know everything. Well, in that case, thank you very much, Martin. Please join me in thanking Martin one more time.
Thank you.
We've got a little bit of time. We are expecting to announce the results of the competition at 5 o'clock. So probably, next on the schedule is probably to come back here for about 4:45 if you want to grab a seat. In the meantime, there might be some free beer to get if you're quick enough. And I don't know if the M&S Percy Pig little stand is still there. So absolutely enjoy yourselves downstairs, and we'll see you back here just before 5 o'clock.